Hi, my name is Catherine Gloston, and today I'm going to talk about understanding by design and Bloom's taxonomy, our module 2 video presentation. And I will start off by apologizing for any beeps that you hear. Unfortunately, this is my best hideout spot. So, moving forward, our agenda for today is first to talk about UBD, then to talk about the application of UBD, then we'll talk about Bloom's taxonomy and the application of Bloom's taxonomy. Finally, I will get into my instructional design project to give you the basically the overview, although I'll be going over some of them through the application process, but I'll just kind of reiterate real briefly at the end. My project will be on the connection of math and science with emphasis on exponents and scientific notation for my first unit. So I know that STEM is very active. However, I want a course that focuses in on the connection of math and science, which kids can relate to, and then they'll feel more comfortable getting inside STEM. So, to begin with the end in mind means to start with a clear understanding of your destination. It means to know where you're going so that you better understand where you are now, so that the steps you take are always in the right direction. By Stephen Covey. So, that made me think about understanding by design because basically you begin with the end in mind. UBD was developed by Jay Matig and Grant Wiggins. It offers a planning process and structure to guide curriculum, assessment, and instruction. So its two key ideas are actually contained in the title, the word understanding and the word design. Need be my gathering of it is why you see understanding, the U capitalized and the D capitalized, because those are the big key words. So one, focus on teaching and assessing for understanding and learning transfer, and design curriculum backward. So the three stages of UBD. Stage one, identify desired results. Stage two, determine assessment evidence. And then stage three, you are planning your learning experiences and instruction. So we'll start talking about stage one first. There are some questions on this slide, and I'll go through them briefly. Some they go as follows: what should students know, understand, and be able to do? What is the ultimate transfer we seek as a result of this unit? What enduring understandings are desired, and what essential questions will be explored in depth and provide focus to all learning. So, as an example of that, one of the takeaways that I got from the video by Wiggins is that when he was using the first thing, the goal, when he asked them to ask some of the other educators to come up with a goal, like the purpose or that mission statement. And one of the instructors, the educator said, well, I want them to, I want them to be able to read and I want them to love to read. And he was like, let's just focus on the love to read, which those learning outcomes, them actually loving to read will actually get them closer to actually being able to read. You may not be the best reader, but if you love to read, then you will develop that ability to be better at reading by continuing to try. So that's something that I kind of took away from there and I thought was really neat. So in there, our established goals are our standards. Now, for me, I'm a math and a science teacher, so I like to try to make that connection for my students on the math and the science and how they intertwine in certain units and in certain bundles of science. So my standards would be like my math standards as well as my science standards. Essential questions, those are those questions that I ask to kind of talk about the transfer, also, well, and the meaning. So, how does the value of my number change when scientific notation changes. Um, so I may talk about like positive zero and or negative numbers. Or I might have my understandings, and those are those big takeaways. So in the math side of it, when I'm talking about exponents and scientific notation, my big understanding may be the value of a number expressed in scientific notation. They may be very large, they may be very small. Knowledge, what they need to know, is I need for them, they will know at the end how to manipulate numbers, or how to manipulate operations on numbers in scientific notation. And then the skills that they'll be able to do is estimate quantities. They may be able to do operations of numbers written in scientific notation. So those are just some skills that they would be able to do. At stage two, determine assessment evidence. Questions that you ask yourself is, how will we know if students have achieved the desired results? What will we accept as evidence of student understanding and their ability to use or transfer their learning in new situations? How will we evaluate student performance in fair and consistent ways? So in this case, now I am faced with a few things. One, I need to create performance tasks. All right. Performance tasks, those are the tasks that students, they apply what they've learned and then they demonstrate their understanding. So as an educator, you want to design your performance tasks at the application level or higher on Bloom's taxonomy. So here they may be applying the properties of integer exponents to generate equivalent expressions. Um, Other evidence, they may do like your pre-assessment. You might have formative assessment. You might have some summative assessments. It might be a project, or it might be some informal methods. I know for me, my students do thumbs up, thumbs down. And also, I have, since with COVID, I've been getting into kind of the groove of kind of trying to read those spaces. You know, sometimes you can tell when a kid is doing a Picasso face, they really don't understand. So the face just tells it all. But exit tickets are my big thing. My kids know normally, like almost every day, it may not be every day, but great deal out of the week, you have an exit ticket. Those are done individually. We do quizzes as assessments, and if you're participating, not only do you get your participation points, sometimes it counts as a grade, sometimes it's just participation. But what it lets me know is, are you at that level where I need for you to be? So those are just some things that I do as far as assessment evidence. Then stage three, plan learning experiences and instruction. Here's the fun part. So how will we support learners as they come to understand important ideas and processes? How will we prepare them to transfer their learning? What enabling knowledge and skills will students need to perform effectively and achieve desired results? And what activities, sequences, and resources are best suited to accomplish our goals? That's like knowing, what textbooks are you using? Are you using textbooks? You might be using an interactive game today. You might be doing some note taking. You might be doing some sprints from out of Engage New York. You might be doing a Khan Academy activity. But you're doing certain activities in a certain order that accomplishes the end goal. So if my end goal is for them to connect scientific notation with the distance between planets, my end goal is for them to be able to know what is scientific notation, to be able to demonstrate scientific notation, um, and create a model of scientific notation with the solar system. So I need to kind of plan out and sequence those activities according to getting them to that level. So I might start off with some simple tasks of just remembering certain things, then kind of understanding what you've been doing since grade 5 builds up and got you to grade 8. We might reach a new level of the application, and then we might be able to analyze and go up and evaluate and then create. But as you notice, planning those learning experiences also puts into perspective for certain educators. You would notice that you're kind of doing certain things like the I do, we do, you do. Now, in that sense, like I discussed with one of my other classmates, I like I do, we do, you do. I think that it's very effective when kind of planning out your lessons, because the I do says what the teacher will do to guide the learning. So that's the model. Then the we do is what we're going to do together during class to prepare for the outcomes that I expect you as a student to do. And then finally, you're going to do that assessment and provide me with the evidence that you understand. So, right there, and those three little simple phrases, I do, we do, you have done things in stage 3, and you reached up to, and you're doing stage 2 activities. So, all about Bloom's taxonomy. Students should be presumed innocent of understanding until proven guilty by the preponderance of the evidence. By Grant Wiggins. Well, and Bloom's taxonomy in 1956, Benjamin Bloom, he collaborated with Max Engelhardt, Edward First, Walter Hill, and David Crothwell, and published a framework for categorizing educational goals. Taxonomy of educational objectives, also known as Bloom's taxonomy. So it started off with the old version in 1956, which you'll see to the left. But then came along in 2001, a new version was created, which a lot of educators are using today. Remembering, understanding, applying, analyzing, evaluating, and then you're at the top level of creating. So, what happened is there are some verbs that help you kind of know what level you're actually, your lesson is actually on, or what your end goal is. So, if you're at the remember stage, you're defining, you're recalling, you're understanding, you are describing, explaining. If you're applying, you're demonstrating. If you're analyzing, you're comparing and contrasting. Evaluating, you might be assessing, and then in creating, you're designing or constructing. So a lot of these things I like, especially on the science side with Bloom's taxonomy, because you'll notice that in certain standards, it'll take you about 2 weeks to actually get through. This was suggested to stay on a certain, what we call a certain scope. Um, for at least 2 weeks, probably longer, because depending on how many actually like bundles you have in the scope. Needless to say, I think Bloom's taxonomy works really, really great when it comes down to science, on the science side, and yes, UVD is kind of more or less on the math side, so they both kind of work really good together. So for the example that I wanted to talk about in the application of Bloom's taxonomy, in the remembering stage. So when in my application, it's the connection of math and science with the emphasis of exponents and scientific notation. So what happens is, one of the things is we're at the level of remembering. And remember, I want to start actually assessing at this application level. That's when I really, really want to assess. Now, for me, I still want to know that they know how, that they remember certain things, that they understand these things. But my higher level of thinking, definitely at that application is when that starts. So remembering is asking yourself, can the student recall or remember the information? In this case, I may ask them, do you remember what is an exponent? Then the understanding may come in, and it says, can the student explain ideas or key concepts. Now, when I'm there, now I'm asking them to state which numbers in scientific notation may be larger. So then they understand which number is bigger, although it's written in scientific notation. In the applying section, I'm asking them to now use their knowledge of conversions to get all of a certain measurement like in that same format. So that same unit. So maybe a measurement of mercury is not written in scientific notation, and I'm saying, hey, I want you to put it in scientific notation. So now you're going to apply that which you remembered and understand. You're going to start applying it. Then analyze says, can the student distinguish between different parts? And in that case, you might be able to tell me, okay, well, this one is how many times larger or smaller than this planet, the distance as far as distance, or maybe even size of the planets. And then evaluate says, can the student justify a stand or decision? So at that point, now we're kind of reaching where we're starting our experimenting. You might be doing a research or some type of project. And then I want you to tell me why Mars is bigger than Venus or whatever the case may be. So now you're going to pull out what is needed and you're going to stand by your decision. Which planet is bigger? And then create, you are now at the point where you're composing, you're creating a product. And in this case, you may be creating a problem involving scientific notation, or in the math and science connection. Now you're going to use what you know about the planets and their size that's in scientific notation, and you're going to use that to create problems that compare and contrast, uh, two planets. And then you're going to design a model that would show the distance between the planets, but also show the solar system. So you'll be able to kind of put that in an actual viewpoint from your point of view. So just to clarify on my instructional project, I am doing what I'm proposing to do is the connection of math and science with an emphasis on exponents and scientific notation, which will be one of the units in that course. The identify the desired results would come from my standards, both math and science. I would talk about what my students will understand, being able to transfer the knowledge that they acquire, as well as the skills, things that they'll be able to do, and the essential questions in stage one. Determine my assessment evidence, that's dealing with the things that I'm going to be assessing them on. I will have rubrics provided. I also use quizzes, uh, pre-assessments, as well as daily exit tickets. And then stage three is the plan for learning experiences and instruction. So my learning activities, like my interactive games, my Nearpods, my quizzes, which is also interactive, and then some think, pair, and share activities. But the other thing is developing my learning activities based on of the where to, which is seen in the Understanding by Design by Wiggins and McTighe. What the W is the where, why, and what. The H is the hook and the hold. The E is for equip your students. The R is for them to be able help them to rethink and revise. E for the self-evaluate. T for the tailor your lessons. And then O is to organize and sequence. And then the connections of math and science, and with the exponents and scientific notation on the Bloom's taxonomy side, that deals with the remember stage is for them to recall their prior knowledge, understand where they're able to state what are rules as far as scientific notation apply, where they use those that knowledge that they have to turn all numbers into scientific notation and comply with the rules, analyze to figure out which one is bigger, determine which one is bigger, evaluate where they're able to pull out and justify an answer based off of a question that's being posed or a prompt, and then they'll create a model that connects the math of scientific notation with the science of the solar system. So that is it. Here are my references. I hope that you enjoyed. I welcome any feedback and I appreciate your time. Thank you.